So far in this lesson we've discussed ATM, virtual channels and circuits, and QoS. Now, let's put it all together and see how it works. We'll look at creating a connection first. Device A's application needs to communicate with device B across an ATM network. Device A sends a connection setup request to its local switch. This request is signaled across the UNI interface and includes information about the destination address and any QoS requirements. This first switch decides if it can support the QoS requirements of the call. This is the contract negotiation. The switch then determines if it can locate the destination address. If the answer to both these questions is yes, a connection is set up. At this point, switch 1 returns a message to device A informing it a connection is being established, and it also assigns a VPI/VCI value to the application. Remember, as we discussed in the previous lesson, the VPI, or virtual path indicator, is the path the data takes across the network, and the VCI, or virtual channel indicator, identifies a segment of the VPI. The switch then forwards the connection request to the next switch in line, requesting that it set up a connection. This request is now sent using NNI signaling. The second switch performs the same process that the first switch does. If it can support the call, it assigns a VPI/VCI number to the connection between the two switches and forwards the call to the next switch, where the same process occurs again. Finally, the call reaches the final switch. Here, the connection setup request is signaled via UNI signaling to the destination station. The destination should accept the call and return a message to this effect to the originator of the connection request. Once the source receives this, traffic is sent. Now, this may sound like a long process, but in most networks, it takes less than a second to accomplish. But what happens if, during the setup process, we have a switch failure? Well, the ATM network automatically reroutes the connection.